So I have my calculator up. I have two equations. I've plotted the graph of cosine x and minus 3 root 2. And if I want to find solutions for that graphically, I can just hit graph. And what am I looking for on the graph? Where it intersects. And the calculator will actually do that for me very nicely. Second, calculate, go down to intersect, hit enter, and then you can manipulate where your cursor is and find that. I found it a little awkward to look for the answer down here. So I adjusted my window just so things move up a little bit. I adjusted my window so that I went from -4 to 0. And then the graph looked a little bit better. And I can actually see what I'm doing. So now I can more clearly see my points of intersection. I can go second calculate, number 5. And I can arrow back along the curve, hit enter. Hopefully it puts me on the second curve and guess. And my calculator will give me an answer of 150 degrees. It will also tell me my second answer by going second calculate, number 5. And now I have to arrow over a little bit to get to what looks like an overlapping point, enter, enter. And now it's 210. Could I have predicted those answers without using intersect? How could I have done it without using intersect? Unit circle, yeah. So the unit circle is one approach. Nolena is looking at hers. I would suggest that's something you do for your diploma. Have a unit circle clearly written out. I might have done this. Go cosine x to the -1 minus root 3 over 2. And it'll actually tell me 150 degrees. And then I throw it in the cast. 150 degrees is there, which is 30 degrees off the x-axis. Go into the quadrant where cosine is also negative, which is quadrant number 3, and that's 210. So that's fantastic. I have actually 3 ways of answering the question: graph it, unit circle it, or use my calculator. Well, what if the equation changes? The data is almost the same, except now I have to graph 2x. So now inside here, I have to insert a 2. What happens with 2x? Yeah, we'll take a look at the graph, right? The graph is pretty fantastic. How many answers will I get for this graph? 1, 2, 3, 4. I'm going to get 4 answers. You could find your answers to start with the same way that we were. So I could find the point of intersection here and here, and there, and answer those questions. But what we want to do is we want to find an algebraic way of solving for this. So let's take a look at the questions that are presented. Compare the solutions. There are 2 solutions versus 4. The values of x. Well, we haven't figured out those other values. Can you please find the other 2 values of x for this first example? So if I go back to my graph and show you my data, can you find the other 2 answers for the point of intersection? So I'm going to pause the recording. I've had my calculator give me the answers. And in the first case, I had x equaling 150 or 210. In the second case, I have the same answers, except there's 4 of them: 150, 210, 255, and 285. And what is actually on the other side here? Is it x? What did I actually solve for? So now when I look at my answers, I have x being 150 or 285. And I actually have 4 answers, x, and I'm going to get those x answers by dividing by 2. X is really 75, 105, 255 divided by 2. Thank you. 127.5 and 285 divided by 2. Is this an okay method of figuring out answers? Do you want a graph every time? Not really. It works if you're stuck, it works, but we want to look at an algebraic way of solving for this. So I'd like you to please turn to page 611, and we're going to try example A algebraically. Page 611. So now I'm asking you to take the inverse sine of negative a half, come up with 2 answers. Your calculator will only give you 1. The answer has to be between 0 and 2 pi, so it has to be positive. So please change it to positive. I'm looking for 2 answers. All right, I want inverse sine of negative a half, and I'm using a skill from our last unit to get 2 answers. I need them to be between 0 and 2 pi, and they need to be positive. This has told me that 2x is equal to 7 pi over 6, or 11 pi over 6. How do I get 1x? Hayden, let's have your calculator going, okay? How do I get 1x? I divide by 2. So now I've got to take both these answers and divide them by 2. Nolena, this might be a little bit different than the method you saw, okay? So I have 7 pi over 12 or 11 pi over 12. I expect that there are 4 different answers to this equation. That sine 2x will be negative a half 4 times between 0 and 2 pi. I found my original answers. These are my original x's. And now to these original x's, I'm going to add pi. Now it would make sense if I would express pi as a fraction of 12. Pi as a fraction of 12 is 12 pi over 12. So I'm going to add 12 pi over 12 to these current values. So my answer is going to be 7 pi over 12. That's one of my answers. Plus 12 pi over 12. So that's 19 pi over 12. Those two are related by a difference of 1 pi. And then I'm going to have 11 pi over 12. That I'm going to add 12 pi over 12 to. So that'll be 23 pi over 12. So I can express, sorry, I just need to record that. I can express my general solutions as 7 pi over 12, the first answer I got, plus any multiple of pi that I want, or 11 pi over 12, the second answer I got, plus any multiple of pi that I want. So we can find all of the answers by adding multiples of the period being either 2 pi over 3 or 8 pi over 12. So you get a sequence of numbers that look something like this. Pi over 12, that was our first answer, plus another 8 pi over 12 is 9 pi over 12. Plus another 8 pi over 12 on that is 17 pi over 12. And because we expect 6 answers in this graph, I'm now going to go to my other answer, which was 3 pi over 12, and add multiples of the period to that. So 3 pi over 12 plus 8 pi over 12 is 11 pi over 12 plus 8 pi over 12 is 20 pi over 12. And this is as close as I can get to 2 pi. If I add another 8 pi over 12 to 17 pi over 12, I get to 25 pi over 12, or 28 pi over 12, which exceeds 2 pi. So my general answer can be written as pi over 12 plus 2 pi over 3n, or 8 pi over 12, 3 pi over 12 plus 2 pi over 3n, or 8 pi over 12, where n is an element of the reals. So this produces quite a challenging method of problem solving. Good luck. The process is a little different than what the workbook suggested, but I think it is easier to deal with. Have fun. Have fun.